Identifying functions. We're going to take some notes here to learn about what a function is, and then how do we determine if something is a function or not. Let's see if we can zoom in a little. Okay. A function, this is a definition now. A function is a rule that assigns each input exactly one output. That, in a nutshell, is the entire definition. Okay, so keep that in mind whenever you're being asked if something is a function or not. Functions occur when every x value is associated with exactly one y value. X is typically your input, y is typically your output. So this is just a generalization. Each x value is associated with exactly one y value. Okay. So if you're looking at tables and ordered pairs, how can we tell if something's a function or not? To test whether or not a table or set of ordered pairs represents a function, look to see if each input or x value has exactly one output or y value. So let's take a look at some examples down below. So here we have a table of values. Okay. So we take a look at our x's and we see if any x value is paired with more than one output. So -2 is paired with 7. Is -2 paired with anything else? No. -1 is paired with 1. Is -1 up here listed again paired with something else? No. 0 is paired with -1. Is 0 paired with anything else? No. There's 1 is paired with 1. 2 is paired with 7. So this is a function. Each x value is paired with only one y value. Okay. All right, number 2. This is a list of ordered pairs. So we're looking to see if any x value is paired with more than one y value. -2 is paired with 1. Is -2 listed as an uh-oh, this is a problem. Here we see -2 is paired with 1, -2 is paired with 8. Okay, right there I know this is not a function. Why? It's because the x value -2 is paired with 2 different y values. Okay? That makes it not a function. Okay, now how about if we were looking at a graph? If a graph represents a function, it should be able to pass a vertical line test, vertical line test. Okay? This means that any vertical line drawn on the graph should intersect the graph at exactly one point. I'm going to show you what that means and also why that's the case. Let's take a look at number 4, for example. If I draw a vertical line, I can hit this graph at more than one place. I can hit it here, here, and here. We say that this fails the vertical line test. It is not a function. I use fxn as shorthand for function. Why is this the case? Well, let's imagine that this x value here, x at this line is, for instance, -2. Well, that means this point here is like -2, -4. This point here is like -2, 1. And this point here is -2, 3. I'm just making up numbers, but that would be the case. -2, 3, -2, 1, -2, -4. Right there, my x value of -2 is paired with 3 different values. That's why the vertical line test tells me if something is a function or not. Now let's take a look at 3. Is there anywhere that we could draw a vertical line and hit the graph at more than one place? No. It passes the vertical line test. I'm going to write vertical line test. So it is a function. How about this one? Is there a vertical line that I could draw that hits the graph at more than one place at one time? No. It passes vertical line test. It is a function. So those are some good examples of functions and no functions. Okay, flipping the page over. How can we tell if a function, if it's a function or not by looking at the equation? An equation represents a function if every input will only result in one output, just like our standard definition of a function. Substitute various input values to see if an equation represents a function. Okay, so let's take a look here. Y equals x squared. Let's plug in, I don't know, let's plug in 2, 1, 0, and see if there are any other outputs that you can get. If I plug in 2, the only output I could possibly get is 4, right? 2 times 2 is 4. If I plug in 1, well, 1 squared is just 1. If I put in 0, 0 times 0 is just 0. There's no other value, right, that one of these values that this would produce. Let's try a negative. I always like to try a negative as well. -2 squared, that's -2 times -2. That's also +4. You can have the same output for 2 different inputs, but you can't have an input have more than one output for something to be a function. So this is a function. Okay, let's take a look at this. All right. Let's say my x is, let's say my x is 4. If x is 4, what squared produces 4? What multiplied by itself produces 4? Well, 2, right? 2 times 2 gives me 4. But look at this. -2 times -2 also gives me 4. So here, the number 4 has 2 different outputs. This is not a function. I'm just going to skip this one for now. We don't need to deal with this equation. I'm not going to give you anything that difficult. What I'd like you to try now is do 9 through 14 on your own.